Hello, hi everyone. I am Nivedita Sharma. How are you all? I hope everyone is doing great. In this video lecture, we are going to discuss some previous year questions of stoichiometry. As you all know, stoichiometry is divided into two parts. Stoichiometry 1, in which we discuss about mole concept, and stoichiometry 2, in which we discuss about redox, or we can say equivalent concept. Before starting doing the questions, you have to understand who will get benefit from this video. This video is only for those students who knows the basics, has NCERT level knowledge and has taken coaching somewhere. Otherwise, it will be very difficult for you to solve the questions along with me. How to use this video now? So first of all, before seeing this video or before starting with this video, you have to revise your notes of the particular chapter. It means if we are doing stoichiometry in today's video, so it means you have to do the revision of the stoichiometry 1 mole concept and the redox before starting the questions. Then you have to write down the important formulas, important parameters of that chapter. And then you can start practice along with me. Okay. If we talk about the weightage as per the JEE Mains, so generally every year two questions are going to come from this topic. But this is the high priority topic. Why? Because this is interrelated with other chapters. This is the core of the physical chemistry. So yes, this is the high priority topic. Without mole concept, you cannot solve physical chemistry perfectly. Okay. Before going with the questions, before solving with the questions, you have to do the revisions of the following topics. Like in mole concept, what you need to do, you have to understand the different formulas which are useful to calculate the number of moles. Then stoichiometry part. In the stoichiometry part, it means you have to apply the mole concept in chemical reactions. That part you can solve by mole-mole relationship, even volume by volume relationship. Then we have the limiting region, excess region concept. We have different kinds of reactions, parallel, sequential reaction, then percentage purity concept, percentage yield of the reaction, in which we are going to use the mole concept. Then we have the concentration terms. Concentration terms means fraction, mass by mass percentage, volume by volume percentage, molarity, molality, normality, parts per million. These are all concentration terms that we have to understand that we are going to do questions from these topics. Then we have redox reaction. In the redox reaction, you should know what are redox reactions, what are the types of redox reaction, how to do the balancing of redox reaction with respect to oxidation number method. Because generally we are going to use the oxidation number method in order to balance the chemical reaction or in order to balance the redox reaction. In the equivalent concept, we are going to use the normality concept, and then by using the equivalent concept, we are going to discuss the questions related to redox titration. I hope I am clear. Now let's start solving the questions. Question number 1. When Fe.93O is heated in presence of oxygen, it converts to Fe2O3. The number of correct statements from the following. Statement number 1 is the equivalent weight of Fe.93O is molecular weight divided by 0.79. We know that equivalent weight, it is equal to molar mass or molecular weight divided by n factor. So it means we have to find out the n factor. So let's find out n factor. So we have Fe.93O, it is heated in presence of oxygen and it is converted to Fe2O3. So here we write oxidation state of iron as 0.93x plus 1 atom of oxygen, and oxidation state of oxygen is -2, that is equal to 0 because charge on compound, it is equal to 0. So we have 0.93x minus 2 is equal to 0. So on solving we get x is equal to 200 upon 93. Similarly, if we find out the oxidation state of iron over here, so this comes out to be x is equal to plus 3. Okay. Up now, in order to calculate n factor, we have to calculate the change in electron. So change in electron we have to calculate. So change in electron, it is equal to 3 minus 200 upon 93. which is equal to 3 into 93 minus 200 upon 93. On solving, we get 279 minus 200 upon 93, and this is going to be 79 upon 93. Clear? So this is the change in electron, that is equal to 79 upon 93. So change in electron is equal to 79 upon 93. Okay. So now n factor of Fe.930, it is equal to number of atoms of iron into change in electron. So number of atoms of iron is equal to 0.93 and change in electron it is equal to 79 upon 93. Right? So if you solve this, you get answer is 0.79. ठीक है? It means statement A is correct. Statement A is correct because we have n factor is equal to 0.79. So equivalent weight is equal to molar mass divided by n factor. So statement A is true. Now let's check for second statement. So second statement says the number of moles of Fe2 plus and Fe3 plus in 1 mole of Fe.930 is 0.79 and 0.14 respectively. It means we have to find out the number of moles of Fe2 plus and Fe3 plus. So basically what happens, this is Fe.930. So in this, some part is Fe2 plus and some part of iron exists in Fe3 plus oxidation state. Okay. So now in order to calculate this, we know that total positive charge is equal to total negative charge in compound. Okay. I am assuming कि let's suppose कि percentage of iron 2 plus is x. Yep. Number of moles of iron 2 plus is x mole. So iron 3 plus mole is going to be 0.93 minus x. ठीक है? Up now, total positive charge is equal to total negative charge. In order to calculate total positive charge, how can we calculate? We have x moles of iron, so x mole plus 2 plus how many moles of Fe3 plus? 0.93 minus x and here plus 3, and that is equal to total negative charge. That is equal to total negative charge, and total negative charge is due to this oxygen. So that is equal to 2. Understood? There is no need to write the sign. So we can also write 2x plus 3 into 0.93 minus 3x, it is equal to 2. Okay. So we get minus x plus 3 3s are 9, 9 3s are 27. So we get 2.79. It is equal to 2. So we get x is equal to 0.79. X is equal to 0.79. ठीक है, x का value is equal to 0.79. So it means number of moles of iron that is equal to 0.79, and here moles of Fe3 plus is going to be 0.93 minus 0.79, which is equal to 0.14 mole. Clear? 0.14 mole. So in the statement this is given, we have 0.79 of Fe2 plus and 0.14 of Fe3 plus respectively. So it means this statement is also true. ठीक है? Now let's see statement number C. ठीक है? Let's see statement number C. Statement number C says Fe.930 is metal deficient with lattice comprising of cubic closed packed arrangement of O2 minus ions. Fe.930 is electron deficient? Yes, it is electron deficient. Why? Why it is electron deficient? Because suppose कि we have FeO, मतलब iron oxide exists in FeO. It means iron is in +2 oxidation state. So on heating, what happens? On heating, some part of Fe plus 2 is converted to Fe plus 3. And if some part of Fe plus 2 is converted to Fe plus 3, it means now we do not have more of Fe2 plus in the system. See, मतलब just try to understand in that way. कि suppose we have this is Fe plus 2, Fe plus 2, Fe plus 2, and this is O2 minus, ठीक है, and O2 minus, kind of this situation, Fe plus 2, Fe plus 2, Fe plus 2. I am saying that some part of Fe plus 2 is converted to Fe3 plus. Some part of Fe plus 2 is converted to Fe3 plus, or some moles of Fe plus 2 is converted to Fe3 plus. Now what to do in this? ठीक है. अब now we have to maintain the positive and negative charge because the compound is going to be the neutral. 2 Fe3 plus replaces 3 Fe plus 2, right or wrong? Because 2 Fe plus 3 means plus 6, replaces 3 Fe2 plus means plus 6. So it means 3 Fe3 plus replaces 2 Fe3 plus replaces 3 Fe2 plus. 3 Fe2 plus. It means now we do not have this, do not have this, do not have this. Now out of 3 positions, 2 positions are occupied by Fe3 plus. Now one position is vacant, and if one position is vacant, so it means this is electron deficient. This is what? This is going to be electron deficient, right? So this is electron deficient, and yes, this is CCP structure, closed packed structure. This is factual statement, and this is factual, and option C is also true. Okay. Now let's see the option number D. The percentage composition of Fe2 plus and Fe3 plus. Percentage. Now we have to find out the percentage. So from second statement we can find out the percentage. How? See, देखो percentage of Fe2 plus, total moles of Fe2 plus 0.79 divided by 0.93 total into 100. So when you solve this, you get how much value? 0.79 this. You get 84.9%, and which is equivalent to 85%, right? Up now, how to solve this one? How to solve this one? Here we have Fe3 plus 0.14 mole. So in order to calculate percentage of Fe3 plus, 0.14 moles of Fe3 plus divided by total moles 0.93 and into 100. So when you solve this, you get 15%. So this statement is also correct statement. So it means the number of correct statement from the following is total statement. Answer is going to be 4. ठीक है? So all the 4 statements A, B, C and D, they are correct. Okay, A, B, C and D, they are correct. Is it clear? Okay. Let's move to next question. Question number 2. The number of units which are used to express concentration of solution from the following is concentration. So what is the concentration? Concentration is amount of solute present in a solution. ठीक है? And that amount we can find in terms of mole, mass and volume. So different expression concentration terms, they are mass percent, yes, mass percent, it is true. Mole, no, mole is not concentration term. In terms of mole we can express the concentration. Mole fraction, yes. Mole fraction, yes. Mole fraction is what? Number of moles of one component divided by total moles. That is going to be mole fraction. Molarity, yes. Molarity, yes. ppm, yes. Molality, yes. So out of all, how many concentration terms? Total 1, 2, 3, 4, 5. So the answer is going to be 5. Clear? Okay. Now next question. Let's do next question. Next question says, what is the mass ratio of ethylene glycol required for making 500 gram of 0.25 molar aqueous solution and 250 ml of 0.25 molar aqueous solution? Okay. So here molarity is given from this 0.25 molar aqueous solution. So molarity is 0.25 molar. Aqueous solution, it means volume of solution is given. The volume of solution is 250 ml. Okay. And we have to find out the mass of ethylene glycol. It means we have to find out mass of solute. mass of solute. So how to find out the mass of solute? To see, we know that molarity, it is equal to number of moles of solute, divided by volume of solution in liter. If the volume of solution is in ml, so I have to multiply the numerator with 1000. Okay, let's do this. So molarity is equal to number of moles of solute. Number of moles of solute is given mass of solute, which is WB, divided by molar mass of solute, and molar mass of solute is given 62. Volume of solution is 250. It is in ml, so that's why into 1000. And this molarity is 0.25. Okay, but this molarity is 0.25. So when you solve this, suppose this is W dash B. So W dash B is going to be 0.225 into 250 into 62 divided by 1000. Okay. So once you solve this completely, you get the value 3.875. It means itne gram of ethylene glycol is required to make the solution of this concentration, which is 0.25 molar. Similarly, we have to solve for this statement. Required for making 500 gram of 0.25 molar aqueous solution. Molar means molality. Molar means molality. Molality is also 0.25 molar. Molar. But molality, how to solve molality? Molality is number of moles of solute. Number of moles of solute divided by mass of solvent in kg. But if mass of solvent is in grams, then we have to multiply the numerator with 1000 in order to convert mass of solvent into kg, right? Number of moles of solute, WB, MB, obviously 62 we have to take. Okay? Now into 1000, mass of solvent. How to calculate mass of solvent? So mass of solvent is equal to mass of solution minus mass of solute. Okay, mass of solution minus mass of solute. Mass of solute, mass of solution required for making 500 gram, right? 500 gram. So it means mass of solution is 500. So it means 500 minus WB. Okay, because mass of solute is WB. So we are going to write 500 minus WB. Clear? Okay, and molality is 0.25. When you solve this completely, so you get WB is equal to 7.63 gram. Ab now, in the question, we have to find out the mass ratio. Mass ratio. It means mass ratio of ethylene glycol, that is WB is to W dash B. We have to calculate. So this is 7.63 and this is 3.875. Up now, in order to simplify it, we are going to do 7.63 divided by 3.87 is to 3.875 divided by 3.875. This is 1.9 and this is going to be 1. So we can write as 2 is to. So answer is 2 is to 1. Answer 2 is to 1. It means option number 3 is the correct answer. Okay, option number 3 is the correct answer. Answer option 3. Okay, let's do next question. Next question. Number of hydrogen atom per molecule of hydrocarbon A. We have A, which is hydrocarbon, having 85.8 percentage carbon. Okay, and we have to calculate number of hydrogen atoms per molecule. Now how to calculate number of hydrogen atom per molecule? So see, 85.8 percentage carbon means 85.8 gram carbon is present in 100 gram of compound. So if 85.8 gram carbon is present in 100 gram of compound, then mass of hydrogen is going to be 100 minus 85.8 gram, which is equal to 14.2 gram. ठीक है. अब now what we are going to do, we have to calculate number of moles of carbon and hydrogen. So see, number of moles we have to calculate. So carbon and hydrogen, for carbon and hydrogen. So number of moles of carbon given mass divided by molar mass. So given mass is 85.8 divided by 12, and here it is 14.2, and molar mass of hydrogen is 1. It is going to be 7.15 mole, and this comes out to be 14.2 mole. Now we have to find out the simplest moles. Simplest moles 7.15 divided by 7.15 or 14.2 divided by 7.15, which is equal to 1, and that is equal to 2. So from simplest moles we can find out empirical formula. So empirical formula, it is equal to EF, and that is C1H2. Empirical formula is CH2. Now let's calculate empirical mass. So empirical mass is 1 into 12 plus 2 into 1, which is equal to 14 gram. 14 gram. But now in the question, we have molar mass of hydrocarbon as 84 gram per mole. 84 gram per mole hydrocarbon mass. Molar mass, it is equal to 84 gram. So it means we have to calculate some factor which we have to multiply with empirical formula in order to get the molecular formula. So it means n, value of n is going to be molar mass divided by empirical mass. Molar mass, it is equal to 84, and empirical mass, it is equal to 40. So that is equal to 6. Empirical formula CH2. So it means molecular formula is 6CH2, which we can write as C6H12. Now we can calculate percentage of hydrogen. So percentage of hydrogen, that is going to be, or we can say how many hydrogen atoms are present in one molecule, right? We have to calculate number of hydrogen, right, per molecule. So that is equal to 12. 12 atoms of hydrogen, right? They are present in one molecule. So answer is going to be 12. ठीक है? Clear? Okay. Let's do next question. So what is next question? On complete combustion, 0.492 gram of an organic compound gave 0.792 gram of CO2. On complete combustion, 0.492 gram of an organic compound. So we have organic compound which is 0.492 gram, and on combustion, it means on reaction with oxygen, it gave CO2 which is equal to 0.792 gram. It means whatever amount of carbon is present in hydrocarbon is converted to CO2. And if I want to find out the percentage of carbon in the compound, so we have to calculate from the CO2. So see, 1 mole of CO2, 1 mole of CO2 has 1 mole of carbon. 1 mole of CO2 means 44 gram of CO2. So 44 gram CO2 means 12 gram carbon. So 0.792 gram CO2 means 0.792 gram of CO2 means 12 upon 44 into 0.792 gram carbon, right? 0.792 gram carbon, which is equal to 0.216 gram carbon. Now let's calculate percentage of carbon. It means mass of carbon divided by mass of organic compound into 100. Mass of carbon is 0.216 Mass of organic compound is 0.492, 0.492 and into 100. So once you solve, you get 43.9%. Okay, so answer is 43.9%, but you have to report this in nearest integer. So 43.9% is equal to 44%. So answer is going to be 44. Clear? So the answer is 44. Let's do next question. Next question says zinc reacts with hydrochloric acid to give hydrogen and zinc chloride. Zinc reacts with hydrochloric acid to give zinc chloride and hydrogen gas. And we know that when metal reacts with acid, it produces salt and hydrogen gas. Now, question says the volume of hydrogen gas produced at STP. So we have to find out the volume of hydrogen gas at STP from the reaction of 11.5 gram of zinc with excess of HCl. So if one of the reactant is in HCl, so there is no need to check the limiting region. It means from the number of moles of zinc, we can find out the number of moles of hydrogen. And once we find out the number of moles of hydrogen, we can convert those moles into the volume. So how to do this? See, number of moles of zinc, it is equal to 11.5 divided by molar mass is given, that is 65.4. It is given 65.4. So 11.5 divided by 65.4, it is equal to 0.176 mole. Okay, this is 0.176 mole. Now, 1 mole of zinc gives 1 mole of hydrogen. Na? So it means 0.176 mole of zinc gives 0.176 mole of hydrogen. Okay. Now, at STP, 1 mole of any gas, it is equal to 22.7 liter. It is given in the question, 22.7 liter. So 0.176 mole of hydrogen gas is equal to 0.176 into 22.7 liter. So once you solve it, you get 3.99 and the answer is 4 because you have to report in nearest integer. So the answer is going to be the 4. Clear? Is it clear? Let's do next question. Next question. When an hydrocarbon A undergoes complete combustion, it requires 11 equivalents of oxygen and produces 4 equivalents of water. And if hydrocarbon is there, so it means along with water, CO2 is also produced. Na? So it means first we have to write that equation in which every atom is balanced. General equation. So let's do general equation. CXHY in presence of oxygen. So it is converted to XCO2 plus Y by 2 H2O. And here coefficient of oxygen is going to be X plus Y by 4. So from the question, Y by 2 value is equal to 4 because 4 equivalents hai. So it means Y ka value is 8. Okay. Now oxygen equivalent is 11. So it means we can say X plus Y by 4, it is 11. Now let's put the value of Y over here. So X plus 8 by 4, it is equal to 11. Okay. So from here, X the value is going to be 9. Okay. So now we can find out the molecular formula. So carbon, how many carbon? 9. Because X say, right? X ka value is 9 na. So X is this only. Right. So C 9 and H 8. Clear? So the answer is going to be option number 1. Clear? Next question. Assume carbon bonds according to following equation. 2 carbon solid plus oxygen gas gives 2 CO. So let me write this. 2 carbon solid plus oxygen gas and it gives 2 carbon monoxide gas. Now question says when 12 gram of carbon is burnt in 48 gram of oxygen. It means it is 12 gram. So when 12 gram of carbon is burnt in 48 gram of oxygen, then the volume of carbon monoxide produced is at STP. So it means in order to find out the volume of carbon monoxide, first we have to calculate the number of moles of carbon monoxide. Okay. Now, as you can see over here, amount of both the reactants are given to us. It means first step is to find out the limiting reagent. In order to find out the limiting reagent, first we calculate the number of moles. So number of moles of carbon is going to be given mass of carbon, which is 12, divided by molar mass of carbon, which is also 12. So here mole is equal to 1 mole. Okay. Now let's calculate the moles of oxygen. So here given mass of oxygen is 48 and molar mass is equal to 2 into 16, which is 32. So on solving 48 upon 32, we get 1.5 mole. Okay. Now in order to calculate limiting region, so there is a trick, there is a way to do this. What is the way? Like number of moles, just give me a moment. Yes. So number of moles of carbon divided by its coefficient, which is 2. Okay. And here number of moles of oxygen 1.5 divided by its coefficient, which is 1. Right. So this is going to be 0.5 and this is going to be 1.5. So 0.5 is least in number. So if 0.5 is least in number, it means carbon is going to be the limiting reagent. What? Carbon is going to be the limiting reagent. Now, amount of carbon monoxide depends upon carbon monoxide depends upon carbon, because carbon is the limiting reagent, right? So, in order to calculate number of moles of carbon monoxide, as you can see over here, 2 moles of carbon gives 2 moles of carbon monoxide. We have 1 mole of carbon. So 1 mole of carbon gives 1 mole of carbon monoxide, right? So 1 mole of carbon gives 1 mole of CO, right? Because here carbon is the limiting reagent. Okay. Now 1 mole of any gas at STP, it is equal to 22.7 liter, right or wrong? So we have moles of carbon monoxide as 1 mole. So the volume is going to be 22.7. We have to report the answer in 10 to the power minus 1, right? So question may, it is dash into 10 to the power minus 1. It means I can write this as 227 into 10 to the power minus 1 liter. So the answer is going to be 227. I hope this question is clear. Now let's do the next question. So the next question is, the density of 3 molar solution of NaCl is 1 gram per ml, and we have to find out the molality of the solution, and molality of the solution is dash into 10 to the power minus 2 molal. Okay, so when we have this kind of information, so we have to form 3 into 3 table. Okay, so on one column we have to write solute, then solvent, and then solution. And here we write mass, volume, and density. Now we are going to write the information in this table. So let's write down the information in this table. So the first is the density of 3 molar solution. 3 molar solution means 3 moles of NaCl is present in 1 liter volume of solution. 1 liter volume of solution. So volume of solution is 1 liter. So volume is this and solution is this. So we write 1 liter, or we can also write 1000 ml. Okay, we can also write 1000 ml. Now the next part, we have to find out mass of solute. So moles of solute, which is NaCl, that is equal to 3 mole. Okay, so mass of solute NaCl is 3 into molar mass of NaCl. Molar mass of NaCl is 58.5. So On solving, we get 175.5 gram. Okay, we get 175.5 gram. So let's try to write this 175.5 gram. ठीक है. Density of solution is 1 gram per ml. We have to find molality of solution. So for molality, we need number of moles of solute divided by mass of solvent. And if mass of solvent is in grams, then we have to multiply the numerator with 1000. Okay, we have to multiply the numerator with 1000. Okay, bete? 1000, 10 to the power 3. Clear? So number of moles of solute is 3. Now we have to find out the mass of solvent. The mass of solvent we are going to find out from this table. How? So see, from density formula, density is equal to mass upon volume. So density of solution is equal to mass of solution divided by volume of solution. So mass of solution is density into volume. So density is 1 and volume is 1000, which is equal to 1000 gram. Okay. Now mass of solvent is going to be 1000 minus 175.5 gram. On solving, you get 824.5 gram. Okay. So just we have to put the values. So this is 824.5. So on solving, we get 363.8 into 363.8, right? Or we can say that we get 3.638. Okay, 3.638. We have to report this in 10 to the power minus 2, right? So we can convert this as 363.8 into 10 to the power minus 2. Okay, and in nearest integer we have to report this number as 364. So the answer of this question is 364. Okay, so the answer of this question is 364. Now let's do next question. So next question, the molality of a 10% volume by volume solution of dibromine solution in CCl4. So we have solution Br2 in CCl4. Okay, so we have to find out the molality. Molality is X and we have to report the molality in terms of 10 to the power minus 2. So it means molality is X into 10 to the power minus 2. And what is molality? Moles of solute divided by mass of solvent in kg. ठीक है? Now Br2 is the solute and CCl4 is the solvent. So this is 10% volume by volume. 10% volume by volume means 10 ml of Br2 in 100 ml of solution. 100 ml of solution, which means not mass, volume of CCl4, it is equal to 100 minus 10, which is equal to 90 ml. Okay, so volume of CCl4 is 90 ml and volume of Br2 is 10 ml. It means volume of solute is 10 ml. In question, density is given in terms of gram per ml. Okay, so now from the density formula, so if I say this is Br2 and this is CCl4, so volume here is 10 ml, here volume is 90 ml. Density is given. Density of Br2 is 3.2 gram per ml. 3.2 gram per ml. Gram per centimeter cube means 3 gram per ml only. 3.2 gram per ml. And here density is equal to 1.6 gram per centimeter cube, which is 1.6 gram per ml. So from density formula, density is equal to mass upon volume, we can find out the mass of Br2. So let's find out the mass of Br2. How? So see, mass of Br2 is going to be density into volume, which is 3.2 into 10, and that is equal to 32 gram. Okay, and here mass of CCl4 is equal to density into volume, 1.6 into 90. So on solving 1.6 into 90, we get 144. So mass of solvent is 144 gram, right? So mass of solvent is 144 gram. Molar mass of Br2 is already given 160 gram per mole. It means we have to put everything in this formula. Molality is equal to number of moles of solute, which is mass of solute 32 divided by mass of molar mass of solute, which is 160, into mass of solvent, which is 144, but that is in gram, so we have to multiply the numerator with 1000. On solving, you get 1.388, or you have to report this answer in terms of 10 to the power minus 2. So we can write 138.8 into 10 to the power minus 2, which is equal to 139. So it means answer, reported answer should be 139, not 138, because we have to report the answer in nearest integer. Is it clear? Okay. Now let's do next question. So next question says 5 moles of BaCl2 is mixed with 2 moles of sodium phosphate. Then it is converted to barium phosphate and then NaCl. So as you can see over here, the equation is not balanced. So first we have to balance the equation. So here we have 3Ba. So I am writing 3Ba. Okay. Now 3Ba hai. So by doing so, we get 6Cl minus na. 3 2s are 6. So 6Cl minus. So we write 6 over here. ठीक है. अब now we have to write 2 over here. So in question we have 5 moles of BaCl2 and 2 moles of Na3PO4. Na3PO4. So maximum number of moles we have to calculate. It means you have to calculate number of moles. ठीक है. And we have to report the answer in nearest integer. So how to do this question? Now amount of both the reactant is given. So first we have to find out the limiting region. How to find out the limiting region? Number of moles divided by coefficient. So here 5 by 3 and here 2 by 2. So it means this is greater than 1 and this is equal to 1. So this is least in number. So if this is least in number, so sodium phosphate is limiting region. Right? Sodium phosphate is limiting region. Now we are going to find moles of barium phosphate with respect to sodium phosphate. How? Number of moles of sodium phosphate divided by its coefficient is equal to number of moles of barium phosphate divided by its coefficient. Number of moles of sodium phosphate 2 moles divided by coefficient 2. Number of moles of barium phosphate we have to calculate. Let's take it as n, and coefficient is 1. Here the coefficient is 1. So this is n upon 1. So here answer is 1 mole. So moles of barium phosphate formed is equal to 1. So answer is equal to 1. Okay, that's it. Now let's do next question. 0.5 gram of an organic compound with 60% carbon. We have the organic compound which is X, and this is 0.5 gram, and it consists of, or it contains 60% carbon, and on combustion it produces X into 10 to the power minus 1 gram of CO2. So we have to find out the value of X. We have to find out the value of X. So how to do this? So first of, we know that what is the concept? Concept is the amount of carbon present in organic compound is converted to CO2, completely converted to CO2. And if it is completely converted to CO2, so if somehow we can find out the mass of carbon in organic compound, then from that mass of carbon we can find out the mass of CO2. Let's try to do this. So see, 0.5 gram hai, and in this 60% of carbon hai. So mass of carbon is going to be 60% of mass of organic compound, which is equal to 60 upon 100 into 0.5. So on solving, we get 0.3 gram. Okay, so on solving, mass of carbon is 0.3 gram. Up now, we know that 1 mole of CO2 consists of 1 mole of carbon. 1 mole of CO2 means 44 gram of CO2. So 44 gram of CO2 gives 12 gram carbon, or it has 12 gram of carbon. So now in 1 gram carbon, we have 44 by 12 gram CO2 because we have to find out the mass of CO2. In organic compound, we have 0.3 gram carbon. So from 0.3 gram carbon, we can find out the mass of CO2. How? 44 by 12 into 0.3. Right? So on solving, we get 1.1 gram CO2. We have to report this answer in terms of x into 10 to the power minus 1, right? So we can say 11 into 10 to the power minus 1. So reported answer is going to be 11. Clear? That's it. Now let's do next question. Okay, next question is easy. It's very easy. Next question is very easy. It is based on significant figures. So which of the following have same number of significant figures? So suppose if we have A is 0.00253. So we know that all non-zero digits are significant. So we have certain rules for that, right? You can have a look for that, right? You can take a look of NCRT in order to understand the significant figures rules. Otherwise, I am going to explain some of the rules over here. So 0.00253, all non-zero digits are significant. So here total number of significant figures, they are equal to 3. Okay. Now if we see B, 1.0003, right? So zeros between non-zero digits are significant. Non-zero digits are significant. So here also, total number of significant figures, they are equal to 3. No, not they are not equal to 3, but they are equal to 5. Right? 5. 5 how? 1, 2, 3, 4, 5. Here 1, 2, 3. Okay. Now next 15.0. C is equal to 15.0. So here significant figures 1, 2, 3. 0 भी. We have to count 0 also. 0.0 है, so it means 0 is also significant. So here significant figures 3. Now D 163. So 163 है, so here so also 3. Total 3. So question says which of the following have same number of significant figures? So same number of significant figures. This A, C and D. So answer is A, C and D. So from the option number 4 is the correct answer. Clear? Okay. Now let's do next question. So number of molecules and moles in 2.8375 liters of O2 at STP are respectively. So 2.8375 liters of O2, right, at STP. So number of moles we have to calculate. So see, we know that volume of 1 mole of any gas is equal to 22.7 liter beta. Okay, 22.7 liter. So in 1 liter we have 1 upon 22.7 mole. So in 2.8375 liter we have 2.8375 divided by 22.7 mole. On solving we get the answer 0.1254. So number of moles, they are equal to 0.125. Okay. Now we have to calculate number of molecules. So in 1 mole we have Na molecules. Yani 1 mole of O2 have Na molecules. So 0.125 mole of O2 is equal to Na into 0.125 molecules. Here we have to write down the value for Na. So Na is 6.022 into 10 to the power 23. into 0.125 molecules, right? So on solving, we get 0.752 into 10 to the power 23 molecules. That's it. Okay. So as per the option, we have answer equal to, इसको we can also write 7.52 into 10 to the power 22 molecules. So as per the option, we can say 10 to the power 22.250. So option number B is not option number B, option number D is the correct answer. So option D is correct. Okay, bete, option D is correct. Clear? Let's do next question. So, okay, this is theoretical, or we can say assertion reason question. So question says, given below are two statements, one is labeled as assertion A and other is labeled as reason R. Okay, assertion A, 3.15 gram of hydrated oxalic acid dissolved in water to make 250 ml solution will result in 0.1 molar oxalic acid solution. And molar mass of, reason is molar mass of hydrated oxalic acid is 126 gram per mole. It means if I'm saying oxalic acid is was dicarboxylic acid, COH, we can also write this as H2C2O4, or we can say 2H2O. This is one of the hydrated form of the oxalic acid, right? So if I find out the molar mass, so the molar mass of this one, it is equal to 2 into 1 plus 2 into 12 plus 4 into 16, and molar mass of water is 18. So on solving, we get 126 gram only. Okay, so it means reason to correct है. Reason is correct, right? Reason is correct if the hydrated molecule, in the hydrated molecule we have two molecules of water. ठीक है. अब now we have to find out the what? Molarity. Okay. So it means if I want to find out the molarity, so molarity means number of moles of solute, which is given mass 3.15, 3.15, molar mass 126, and volume is 250 ml. 3.15 given mass, molar mass 126, and volume is 250 ml. So it is in ml, so obviously we have to multiply by 1000 in order to convert the volume into liter, right? So on solving, we get 0.1 liter. It means assertion, here see 0.1 molar oxalic acid solution. It means assertion is correct and reason is correct. Reason is correct, right? And it is also the correct explanation of assertion, because if we take different part of or different hydrated form of the oxalic acid, so molar mass can be different. So we can say both A and R are true, and R is the correct explanation of the assertion. So option C is the correct answer. Okay, let's do next question. Match. We have to do the matching. So see, A, 16 gram of methane. 16 gram of methane means 1 mole of methane. Why 1 mole of methane? Because obviously in 1 mole, 1 mole methane mass is 16. 12 plus 4, which is equal to 16. Okay, so that is equal to 1. So in 1 mole, what is going to happen? How many electrons, your weight and all. So we have to check. Abhi, this is 1 mole. So do next part, and then we will do the matching. Next is 1 gram of hydrogen. 1 gram of hydrogen means it is equal to 1 by 1 into 2, or we can say 0.5 mole of hydrogen given mass upon molar mass. And if we have 0.5 mole of hydrogen, then the volume of hydrogen gas is STP, that is equal to 11.4 liter at STP. So it means B को we can match with fourth one. ठीक है? Now see, 1 mole of nitrogen gas. So 1 mole of nitrogen gas means obviously 2 into 40, which is equal to 28 gram of nitrogen. So this is also correct. Correct means it means we can match C with first. So C can be matched with first. Okay. Now D. 0.5 mole of SO2. So 0.5 mole of SO2 means 0.5 into molar mass. Molar mass means 32 plus 2 into 16, right? So which is equal to 32 gram. So D को we can match with third. So D को we can match with third. So A को we can match with second. Let's do it. Prove it. Let's prove this. So 1 mole of methane है. तो in 1 mole of methane, how many electrons? In carbon we have 6 electrons, and in hydrogen we have 4. मतलब 1 electron in each hydrogen. So total hydrogen 4. तो 4 into 1 electron. So total electrons 10 electrons. ठीक है, 10 electrons. तो 16 ग्राम मतलब in 1 mole we have 10 electrons ना, और we can say 10 mole of electrons. 10 mole of electrons, and 10 mole of electrons means 10 into 6.022 into 10 to the power 23, which is equal to 60.22 into 10 to the power 23. So A को we can do the matching with the मतलब we can match with the second one. Clear? Okay. Let's do next question. Next question says 25 ml of silver nitrate solution AgNO3, which is 25 ml and this is 1 molar, is added drop wise in potassium iodide. Drop wise in 25 ml and which is 1.05 molar. The ion present in very small quantity in the solution. So this is a kind of precipitation reaction. So when you add AgNO3 drop wise in Ki solution, then we get the precipitate of AgI and which is yellow in color. Okay, which is yellow in color. So what happens? जैसे if we find out the millimoles over here, यानी molarity into volume ml में, so 1 into 25 ml, so which is 25 millimole, and here 1.05 into 25, which is around 26 millimole. Okay, so when you add AgNO3, then what happens? I minus from Ki, right, combines with Ag plus to give the AgI precipitate. So it is the precipitation reaction, double displacement reaction. Then what happens? What is going to happen? The ion present in very small quantity in the solution, that is going to be Ag plus and I minus only. ठीक है, Ag plus and I minus only. I hope this question is clear. Now let's do next question. Next question. A solution of sugar is obtained by mixing 200 gram its 25% solution and 500 gram of its 40% solution, both by mass. मतलब mass by mass percentage is given to us. The mass percentage of resulting sugar solution is, see, solution 1, and we have solution 2. So in solution 1, we have 200 gram and 25%, 200 gram solution. And here we have 500 gram solution and 40%. Mass percentage of resulting solution, yani when we combine solution 1 with solution 2, so we get final solution. Solution final. Okay, we get solution final. Ab now see, देखो, we can find out the mass of sugar in this solution. How? Mass of sugar is equal to 25 into 200 upon 100. How? Because mass by mass percentage is equal to mass of sugar divided by mass of solution and into 100, right? So I am finding the mass of sugar. So sugar means mass by mass percentage, which is 25, into mass of solution, which is 200, and that is divided by 100. So it means this is going to be 50 gram. ठीक है, तो 50 gram in solution A. Okay. Now mass of sugar in solution B. So mass of sugar in solution B, it is equal to percentage 40. So it means 40 into 500 upon 100, which is equal to 200 gram. So total mass of sugar that is equal to 50 upon 200 and 250 gram. Okay, 250 gram. Total mass of sugar 50 plus 200, that is equal to 250 gram. Now new mass by mass percentage is equal to total mass of sugar total mass of sugar, which is 250, divided by total mass of solution. So total mass of solution is 200 plus 500. So 200 plus 500 into 100. So on solving, we get 35.71 के around percentage है, which is equal to 36%. Okay, which is equal to 36%. So यानी reported answer is going to be 36. Reported answer is going to be 36. Okay, let's do next question. Solution by adding 2 gram of X to 1 mole of water, mass percent of X in solution is. Solution is added by 2 gram of X, yani mass of solute, it is equal to 2 gram. In 1 mole of water, mass of solvent is 1 mole water, and 1 mole water mass is equal to 18 gram water. So mass percentage of X means mass of solute divided by mass of solution into 100. Mass of solute is 2, mass of solution is 18 plus 2 into 100. Okay, so we get 2 by 20 into 100. So we get 10%. So answer is 4. Answer is 4. Okay. Hello, now we are going to do some questions of redox reactions and equivalent concept, which is the part of stoichiometry 2. Let's do it. Question number 1, which of the following options are correct for the reaction? So if you see the reaction properly, so you get some information. So here zinc is in solid state, elemental state. So here oxidation number is equal to 0 for zinc. But if you find out the oxidation number of zinc in the product, so it is going to be X plus 4 atoms, or we can say 4 cyanides, and cyanide oxidation number is equal to -1. So this is going to be 4 minus 1 is equal to the total charge on this complex. So X minus 4 is equal to -2, where X is equal to +2. Okay, so zinc from 0 oxidation state goes to plus oxidation state. So increase in oxidation number, and increase in oxidation number means oxidation. Now we have to check for gold. So this is gold cyanide, gold complex. So let's try to find out the oxidation number by X method. So X plus 2 minus 1, it is equal to -1, because total charge on the complex is -1. See, now X minus 2 is equal to -1, and X is equal to -1 plus 2, which is equal to +1. And here gold is in 0 oxidation state. Okay, so gold from +1 goes to 0 oxidation state, which is the decrease in oxidation number, and decrease in oxidation number means reduction. So the above reaction is redox. It is redox. Okay, now we have an option displacement reaction, decomposition reaction, and combination reaction. So what is displacement reaction? When more reactive element displaces less reactive element from its salt solution. So if you see this reaction, so zinc is more reactive element and it displaces gold from its aqueous solution. So it means we can consider this reaction as the displacement reaction. So it means answer is going to be A and B both. Okay, so option is 3. It cannot be decomposition reaction, because what is decomposition reaction? When single reactant breaks down to give several simpler products. And combination reaction, in which single product is formed from 2 or more reactants. So it cannot be decomposition, it cannot be combination, it can only be redox and displacement. Okay, now let's do next question. Strong reducing and oxidizing agents among the following respectively are. Basically, this question is also the part of F block. F block. So you should know that cerium can exist in +3 oxidation state and +4 oxidation state. Okay, what is cerium? So cerium atomic number is 58, and if I write down the electronic configuration, so it is going to be xenon. Xenon is 54, and xenon belongs to which period? Fifth period. So valence shall be 6s 6p, then penultimate shell 5d, and then anti-penultimate shell 4f. So when we write down the electron, the first electron goes to 6s2, then it goes to this, and then this. Okay. So here total valence electron is total valence electrons, they are 4. So oxidation number can be +4 and +3. Okay, so this is all memory based. This is all what? Memory based. This is the part of F block, memory based. Similarly, europium, europium can exist in +2 and +3 oxidation state. Now EU, that is 63. This is xenon, and this is 4f7 and 6s2. Okay, 4f7 and 6s2. Okay, so the point is strong reducing and oxidizing agent. So reducing agent, what is reducing agent? Which reduces other and oxidizes itself. So EU +2 goes from +2 to +3 oxidation state. Okay, and which one is the oxidizing agent? Which oxidizes other and reduces itself. So it means cerium +4 can go to +3 oxidation state. Understood or not? Right. So answer is going to be 4. Option 4 is the correct. Option 4 is correct. Option 3 cannot be correct. Why? Cerium is +4, na? So cerium is +4. So reducing agent which reduces other and oxidizes itself. So cerium cannot go to the +5 oxidation state or more oxidation state. So this is not true. Even this is not true. Okay. Now Ce3 plus and Ce4 plus, not true. So you can also try the elimination method in order to find out the correct answer. Okay. Let's do next question. Next question says, during the reaction of permanganate with thiosulfate, the change in oxidation of manganese occurs by a value of 3. Value of 3. Identify which of the below medium will favor the reaction. So permanganate is what? Potassium permanganate, KMnO4. And if I write permanganate, so it is going to be MnO4 minus. So oxidation state of manganese over here is X. Oxygen oxidation state is -2, and it is equal to total charge on this species, that is equal to -1. So X ka value is going to be +7 from this. Our question says, when we are going to react this permanganate with thiosulfate is S2O3 2 minus. S2O3 2 minus, and this is also known as the hyposolution, sodium thiosulfate. Okay, so the change in oxidation state of manganese occurs by a value of 3. So if it occurs by a value of 3, it means MnO4 minus is converted to MnO2, because in MnO2 oxidation state is what? X plus 2 minus 2 is equal to 0, and where we can find out X ka value as +4. Okay, so +7 to +4, it means 3 electron change. 3 electron change, it means oxidation number change, that is equal to 3. So identify which of the below medium will favor the reaction. MnO4 minus, right? MnO4 minus in acidic medium is converted to Mn2 plus. So this is not true. And MnO4 minus in neutral or mild basic medium, it is converted to MnO2. So this is the case. This is the case. So answer is aqueous neutral. Understood? Aqueous neutral. Okay. So answer is option 2. Okay. Let's do next question. The volume of 0.02 molar aqueous HBr. So we have HBr. Okay. Aqueous HBr, and its molarity is 0.02 molar. Required to neutralize barium hydroxide, which is 10 ml and 0.01 molar. So obviously HBr is acid, hydrobromic acid, and barium hydroxide is a base. So this is going to be the neutralization reaction, right? This is the neutralization reaction. So in neutralization reaction, we get salt BaBr2 plus water. Okay. So question says how much volume of aqueous HBr is required to neutralize 10 ml of 0.01 molar barium hydroxide. Okay, so what we are going to do, we can do this reaction via two ways, by mole concept or by the equivalent concept. Here I am using the equivalent concept. So HBr plus barium hydroxide. For equivalent concept, there is no need to balance the chemical equation. So here, number of equivalents of HBr is equal to number of equivalents of barium hydroxide. Now, how to calculate number of equivalents? What is the formula to calculate number of equivalents? So, number of equivalents is equal to number of moles into n factor, or we can say normality into n factor, or we can say, or we can normality into n factor नहीं, normality into volume, and next is molarity into n factor into volume. Okay, molarity into n factor into volume. That's how we can calculate the number of equivalents. So here, number of equivalents of HBr, we have molarity and volume. So it means we have to use this formula, na? Molarity into n factor into volume, and here also molarity into n factor into volume. Now volume is in ml. So if volume is in ml, then number of equivalents, they are equal to milli equivalents. They are equal to milli equivalents. If we take volume in ml. Molarity, it is given 0.02. N factor of HBr 1. Why? Because HBr we have one replaceable hydrogen. So N factor is 1. And volume we have to find out is equal to molarity of barium hydroxide 0.01. Volume is 10 and N factor. So barium hydroxide, so we have 2 OH minus, so N factor is equal to 2. So 2. Now we can find out. Let's find out the volume is equal to how much? 0.01 into 20 upon 0.02. So on solving you get 10 ml. Okay. So answer is 10 ml. Answer is 10 ml. It means option 3 is the correct answer. Okay. Option 3 is the correct answer. Now let's do next question. Okay. It means this is a question of balancing. So we have 2iO3 minus plus xi minus in presence of H plus, it gives I2, 6i2 and 6h2 in presence of 12H plus. And you have to find out the value of x. So how to find out the value of x? Simple, it's simple. First, we have to analyze the redox reaction. So this redox reaction is a comproportionation reaction. Let's find out the oxidation number first. So this is going to be x plus 3 minus 2 is equal to minus 1. So x minus 6 is equal to minus 1 and x is equal to plus 5. And here x is equal to minus 1. This oxidation number, not this x. Right, this is the oxidation number, that is minus 1. And here oxidation number, it is equal to 0. I2 का oxidation number, it is equal to 0. It means from IO3 minus, iodine goes from plus 5 to 0. So which is the reduction? Okay. And here in I minus, iodine goes from minus 1 to 0, which is the oxidation, because increase in oxidation number. Here increase in oxidation number, which is oxidation, and reduction में decrease in oxidation number, which is reduction. Okay, that is reduction. So we have to balance this basically in acidic medium. So when we have the cum proportionation reaction concept, So we write IO3 minus I minus, and here I2 is there ना, so we have to write 2 IOT. ठीक है. So here x का value is going to be plus 5, and here x is equal to 0, but for 2 iodine oxidation number is 0, so we have to balance this. So 2. So with respect to 2x, iodine oxidation number is 10. So there is a change of 10 electron, because from 10 it goes to 0. ठीक है, and this is the reduction process. Similarly we have to balance this. So x के लिए -1, but with respect to 2 iodine atom it is -2, and here with respect to 2 iodine atom it is 0 oxidation state. So it means it goes from -2 to 0, so there is a change of 2 electron, and this is called oxidation. Now what we are going to do, I am using oxidation number method to balance. So here what we are going to do, first balance the electrons. Here 10 electrons, here 2, so this should be multiplied by 5. So if I multiply this by 5, so this is going to be 5 and this is going to be 10. Okay, this is going to be 10. So let me rewrite this equation. So after rewriting, we get 2IO3 minus plus 10I minus, and we get 6I2. Now if you see the question, so we have 6I2 over here and 2IO3 minus over here. It means now these are balanced. Next step is to balance oxygen atom. So in acidic medium, if we want to balance oxygen atom, so add water molecules to deficient side. So here we write kitna? 6 oxygen. So it means here we write 6H2. Up now, in order to balance hydrogen, add H plus to deficient side. So here how many hydrogen? 12. So here I am going to write 12H plus, and this is the value of x. So x ka value is 12. X value is 12. Okay, so we have to find out the coefficient of I minus, right? So we have to find out the coefficient of I minus. It means coefficient of I minus is going to be 10. Okay, it is going to be 10. It's not 12. Okay, so answer is going to be 3. Option number 3. Clear? Okay. Let's do next question. Okay. This is theoretical question. Given below are two statements. Statement 1. In redox titration, the indicators used are sensitive to change in pH of the solution. No, it is incorrect. So statement 1 is incorrect. It is sensitive to change in oxidation potential. Oxidation, or we can say reduction potential. Okay, because it's a redox. One element is getting oxidized and another is getting reduced, right? So it is based on oxidation potential and reduction potential. Now second, in acid-base titration, indicators used are sensitive to change in oxidation potential. No. Acid-base reactions are non-redox reaction. है ना? These are non-redox, like HCl plus NaOH. It produces NaCl and water. So here +1, here -1, here +1, oxygen -2, hydrogen +1, here sodium +1, Cl -1, hydrogen +1, oxygen -2. So it's a non-redox reaction. No change in oxidation number. Okay. So it's a non-redox reaction. So here acid-base reactions or acid-base titrations are sensitive to pH change. So they are sensitive to pH change. So statement 1 and statement 2 both are incorrect. The answer is both statement 1 and 2 are incorrect. Option 2 is the answer. Okay. Okay. Let's do next question. In alkaline medium, the reduction of permanganate anion involves a gain of electron. Of right. So basically, I have already discussed this. MnO4 minus in basic medium. MnO4 minus in basic medium is converted to MnO2. MnO2. So here x minus 8 is equal to minus 1. So x is equal to plus 7. And x minus 4 is equal to 0. So x is equal to plus 4. So it gains kitna electron? 3 electrons. Na? There is a change of 3 electrons. So it gains 3 electrons. Okay. So in alkaline medium, the reduction of permanganate anion involves a gain of how many electrons? Obviously 3 electrons. So reported answer is going to be 3. Okay. That's it. Let's do next question. KMnO4 is titrated with ferrous ammonium sulfate hexahydrate in presence of dilute H2SO4. Number of water molecules produced for 2 molecules of KMnO4. That's a simple balancing. Simple balancing. See, MnO4 minus, it is treated with ferrous ammonium sulfate. So ferrous ammonium sulfate means Fe2 plus. ठीक है, ferrous ammonium sulfate hexahydrate in the presence of H plus. ठीक है, तो Fe2 plus है. So MnO4 minus is the oxidizing agent. So Fe2 plus is going to be the reducing agent. Ferrous ammonium sulfate is what? Ferrous ammonium sulfate is this FeNH4SO4. ठीक है, Fe plus 2 ammonium plus 2 or we can say ammonium plus 1. So here total plus 2. So SO4 2. Okay, SO4 2. So that is going to be the formula of ferrous ammonium sulfate, and this is hexahydrate. It means 6H2O. 6H2O. Now the point is ferrous from ferrous ammonium sulfate hexahydrate in presence of H plus is oxidized to Fe3 plus, and MnO4 minus is reduced to Mn2 plus. So first we have to balance the oxidation, balance this redox reaction. So let's do this. This is x minus 8 is equal to minus 1. So x is plus 7. And here x is equal to plus 2. So there is a change of kitna electron? 5 electron. So let's write 5. Here this is plus 2 and here it is plus 3. So there is a change of 1 electron. There is a change of 1 electron. Now what we are going to do, I have to multiply this with 5. So here we write 5, here we write 5 in order to balance the electron. Okay, now the last step to balance oxygen. So here we have 4 oxygen atom. So I am going to write 4H2O over here. Now we have 8 hydrogen. So I am going to write 8H plus over here. ठीक है? So from this redox, from redox, 1 mole of KMnO4 gives 4 moles of water. How much? 4 moles of water. So 2 mole of KMnO4, it gives 8 mole of water, or we can say 8 molecules of water, right? Question says number of water molecules produced for 2 molecules of KMnO4 is. For redox, if we consider redox reaction, then 8 water molecules they are going to produce. But in this we have ferrous ammonium sulfate hexahydrate. We have what? Ferrous ammonium sulfate hexahydrate. So see, this is 5 na, 5 Fe2 plus. When I put the spectator ions back, so we get 5 Fe NH4 2 SO4 2.6H2O dot 6H2O. ठीक है, that is here we have 5. ठीक है, 5. So see, in 1 mole we have 6H2O, right? In 5 mole we have 30H2O. ठीक है, that is with 1 mole of KMnO4. But now in question we should be having 2 moles of KMnO4. It means with 2 mole KMnO4, with 2 mole KMnO4 we have 10 FeNH4 whole 2 SO4 whole 2 6H2O. So with 10 mole we have 60 water molecules, and they are also going to liberate, right? They are also going to produce. So total water molecules 60 from hydrated part and 8 from redox part is equal to 68, is equal to 68. So that's why reported answer is going to be 68. Okay, is it clear? Now let's do next question. 20 ml of calcium hydroxide was consumed when it was reacted with 10 ml of unknown solution. 20 ml of calcium hydroxide was consumed when it was reacted with 10 ml of unknown solution of H2SO4. 10 ml and unknown solution. Molarity is something and we don't know. Okay, we don't know. This is unknown. Molarity is unknown. Now, next. Also, 20 ml standard solution of 0.5 molar HCl containing 2 drops of phenolphthalein was titrated with calcium hydroxide. 20 ml 0.5 molar and it was titrated with calcium hydroxide. ठीक है? The mixture showed pink color when burette displayed the value of 35.5 ml, whereas the burette reading showed 25.5 ml initially. So basically what we are going to understand from this statement is the volume of calcium hydroxide used over here is equal to 10 ml. It is equal to 10 ml. It means calcium hydroxide used to neutralize HCl is equal to 10 ml. Okay. The concentration of H2SO4 is M. It means you have to find out the concentration of H2SO4. So see, 20 ml 0.5 molar calcium hydroxide 10 ml. So from this we can say that the number of equivalents of HCl is equal to number of equivalents of calcium hydroxide. Number of equivalents of calcium hydroxide yani molarity into N factor into volume. Here also molarity into N factor into volume. Volume is in ml, so equivalents, they are going to be milli equivalents weighted. Okay, so molarity is 0.5, N factor only one H plus, one replaceable H plus, so N factor is 1. Just give me a moment. Okay, N factor is 1 and volume is 20. And here molarity we have to find out. N factor is 2 because we have 2 OH minus, 2 replaceable OH minus. So 2 and volume is 10 ml. Okay. So on solving, we get molarity equal to 0.5 molar. That is the molarity of calcium hydroxide. Now this molarity we are going to put over here. So here number of milli equivalents of calcium hydroxide is equal to number of milli equivalents of H2SO4. Again same formula, molarity into N factor into volume. Molarity of calcium hydroxide 0.5 into volume, or N factor is 2 and volume is 20, is equal to molarity we have to find for H2SO4. N factor is 2 because 2 replaceable H plus and volume is 10. So from here molarity is equal to 0.5 into 2, which is equal to 1 molar. Okay, so reported answer Reported answer is 1 molar. Okay, let's do next question. So see the following chemical reaction, sum of X, Y and Z is. It means we have to do balance, right? Balancing. H plus, so it means balancing in acidic medium. I am using oxidation number method to balance this redox reaction. Cr2O7 2 minus plus Fe2O plus, it gives Cr3 plus and Fe3 plus. So first balance the key atoms, which takes place, or we can say which takes part in the oxidation or reduction reaction. So here 2 chromium, so here 2 chromium. Okay. Now let's find out the oxidation number. So here 2x plus oxidation number is -2, that is equal to -2. So 2x minus 14 is equal to -2. 2x is equal to +2. We have 2 chromium atoms now. It means we have to find out the oxidation number with respect to 2 chromium atoms. So here it is x plus 3. On 1 chromium it is +3. So on 2 chromium it is +6. So plus 12 to +6. So there is a change of 6 electron, and this is the reduction process. Similarly, we have to find for Fe2 plus and Fe3 plus. So Fe2 plus +2, and here Fe plus 3 +3 oxidation state. So here there is a change of 1 electron. Okay, and it is the oxidation process. Now next step is to balance the electron. Let's balance the electron. Multiply this by 6. So if I multiply this by 6, so here we write 6, here we write 6. Now last step, देखो, if we compare this equation with the given equation, so we have 6 Fe2 plus and 6 Fe3 plus only. Okay, now the last step, we have to balance the oxygen. So we have 7 oxygen over here, so 7H2. Now we have 7 twos are 14 H plus, 7 twos are 14 H plus. So here we write 14 H plus, 14 H plus. Okay, so from this data we can find out that X ka value is 40 because that is the coefficient of H plus. Then Y, Cr3 plus, so Y is 2 and Z is equal to this water coefficient 7. So let's find out X plus Y plus Z, which is equal to 14 plus 2 plus 7. So 14 plus 7, 21, 21 plus 2, 23. So answer is 23. Answer is 23. Let's do next question. The total change in the oxidation state of manganese involved in the reaction of KMnO4 and potassium iodide in acidic medium. So MnO4 minus with potassium iodide, Ki. So Ki में I minus. Right, so in acidic medium MnO4 minus is converted to Mn2 plus and I minus is converted to I2. So we have to find out the total change in oxidation state of manganese. So here x plus 4 minus 2 is equal to -1, x ka value is +7 and here x ka value is +2. So change is of 5 electron and change in oxidation state is also 5. Change in oxidation state, it is equal to 5. That's it. Okay, let's do next question. 5 gram of NaOH was dissolved in deionized water to prepare a 450 ml stock solution. 450 ml stock, matlab we are preparing this in large amount, right? So NaOH, the given mass of NaOH, this is WB solute, that is 5 gram. Molar mass of NaOH, that is 1 into 23 plus 1 into 16 plus 1 into 1, which is equal to 40 gram. And volume of solution, it is equal to 450 ml. So question says 5 gram of NaOH was dissolved in deionized water to prepare a 450 ml stock solution. What volume of this solution would be required to prepare 500 ml of 0.1 molar solution? So it means we have to find the molarity of this one. The molarity of this solution, suppose this is M1. Okay, so this is given mass upon molar mass into volume of solution. If it is in ml, so into 1000. So WB 5 upon 40 into 450 and into 1000. When you solve this, you get 10 by 36 molar. Now question says, what volume of this solution would be required to prepare 500 ml of 0.1 molar solution? 500 ml of 0.1 molar solution. It means we have to use, because solute is same. Solute is same. So we have to use this equation, m1 v1 is equal to m2 v2. m1 is 10 by 36. We have to find this volume where m2 is 0.1 and 500 ml. So 0.1 and 500 ml. So on solving, we get v1 is equal to 50 into 36 upon 10. So that is 5 into 36, and 36 into 5, it is equal to 180 ml. Okay, so reported answer is 180. Okay, so you have to report answer in 1. Okay, let's do next question. Next question, the density of a monobasic strong acid is 1.21 kilogram per liter. The volume of its solution required for the complete neutralization of 25 ml of 0.24 molar NaOH is. Okay, let's do this. So density of monobasic acid. Density monobasic acid, so I am taking HA. So density of monobasic acid is 1.21 kilogram per liter, or we can say 1.21 gram per ml, right? Gram per ml, because 1.21 into 10, 1 kilogram is equal to 10 to the power 3 gram, and 1 liter is equal to 10 to the power 3 ml. So the value is going to be same. So density is itna, and molar mass of acid is 24.2 gram. So question says, how much volume of this solution is required for the complete neutralization of 25 ml and 0.24 molar NaOH? Okay, so this is the neutralization reaction. So see, we cannot apply the equivalent concept over here. We cannot apply the molar concept over here, because moles of HA or moles of monobasic acid is not there. So first we have to find out the moles of HA. We can say this, if this is the monobasic acid, that is HA, and this is NaOH. So 1 mole of HA required 1 mole of NaOH for complete neutralization. Okay, so we can say that millimoles of HCl is equal to millimoles of NaOH. And how to calculate millimole of NaOH? Molarity into volume ml. So 0.24 into 25. So that is in ml. Okay, 25 ml. So millimole. So millimole, that is equal to 6 millimole. Okay, so 6 millimole HCl is there. अब now, मतलब 6 millimole of HCl is consumed for the neutralization process. From question, Achha, there is no need to write HCl over here na, because HCl is not given. Millimole of HA. We can say millimole of HA is equal to millimole of NaOH, which is equal to 0.24 into 25, which is equal to 6 millimole. So from question, mass of 1 mole of HA, it is equal to 24.2 gram. 24.2 gram. Okay, so mass of 6 into 10 to the power minus 3 mole of HA. It is equal to 24.2 into 6 into 10 to the power minus 3 gram. On solving, you get 145.2 into 10 to the power minus 3 gram. Okay, 145.2 into 10 to the power minus 3 gram. So that is the mass of HA solution. Now density is given. Density is 1.2 gram per ml to 1 gram per ml. And we know that density is equal to mass upon volume. So from this we can find out the volume. How? mass upon density, mass of HA solution upon density. So which is equal to 145.2 into 10 to the power minus 3, and density is equal to 1.21, right? 1.21. So on solving, we get 120 into 10 to the power minus 3 ml. But we have to report this answer in terms of 10 to the power minus 2 ml. So in order to make it 10 to the power minus 2, we write 12 into 10 to the power 1 into 10 to the power minus 3 ml, which is 12 into 10 to the power minus 2 ml. So answer is 12. Answer is 12. Okay. Let's do next question. An indicator X is used for studying the effect of variation in concentration of iodide ion on the reaction of iodide ion with H2O2. H2O2. The indicator X, this is the indicator X, forms blue colored complex with compound A. Compound A. So in compound A, we have iodide minus the I minus. So it means indicator is going to be the starch. Starch and okay, the indicator X in compound A respectively. Starch and iodine. Right. With iodine, starch forms blue color complex. That's clear. This is a memory based and theoretical question. Memory based and theoretical question. So see, answer is 1. Answer is 1. Okay. Let's do next question. The volume of HCl containing 73 gram per liter required to completely neutralize NaOH. HCl, which is 73 gram per liter, required to completely neutralize NaOH. And this NaOH is obtained by 0.69 grams sodium on reaction with water. So we get NaOH over here. Okay, NaOH. Hydrogen gas is also released. Is this? It means we have to find out the volume of HCl. ठीक है. So first of all, we have to find out the moles of NaOH. Moles of NaOH. So how to find out the moles of NaOH over here? See, 0.69 gram of Na. And as per the law of conservation of mass, if we have 0.69 gram of Na and water is in excess, so Na is going to convert into NaOH, and this is complete reaction. Okay. So it means, देखो, we can find out that in 1 mole NaOH, we have 23 gram sodium. So in 1 gram Na, we have 1 by 23 mole NaOH, right? 1 by 23 mole NaOH. And in 0.69 gram Na, we have 0.69 upon 23 mole NaOH, which is equal to 0.03 mole NaOH. It means here we have 0.03 mole NaOH. Okay, we are going to apply the equivalent concept only. So here n factor is 1 only because replaceable OH minus 1. And here n factor is equal to 1. But we have to find out the molarity. So HCl in 1 liter, 73 gram HCl is present. Okay, so we can say 73 upon 36.5 gram or moles of HCl. Number of moles given mass of divided by molar mass. So on solving, here we get 2 mole HCl. In 1 liter we have 2 moles of HCl na? So molarity of HCl is 2 mole per liter. 2 mole per liter. Now we are going to apply the equivalent concept, HCl and NaOH. So number of equivalents of HCl is equal to number of equivalents of NaOH. Okay, so here molarity into volume into n factor is equal to, here molarity is not given, na? NaOH molarity is not given. So we have to use this formula, number of moles into n factor. So molarity is equal to 2, n factor is 1, volume we have to find out, and here number of moles 0.03 and n factor is 1. So volume is 3 into 10 to the power minus 2 upon 2. Okay. So this is going to be 1.5 into 10 to the power minus 2, right, liter, or we can say this is going to be 15 into 10 to the power minus 3 liter, which is equal to 15 ml. Okay, we have to report the answer in ml, so answer is going to be 15. Okay, answer is going to be 15. Let's do next question. Number of electrons involved in the reduction of permanganate to manganese dioxide in acidic medium. Permanganate, in the reduction of permanganate to MnO2. So basically 3 electrons only. ठीक है, or we can say mild acidic medium. It means it's mild, right? Mild acidic, or we can say neutral medium, and also 3 electrons. Because here plus 7 and here it is plus 4. So change in number of electrons, that is equal to 3 electrons. So report your answer. Report the answer in terms of 3. Report the answer in terms of 3. Let's do this question. KMnO4 oxidizes I minus in acidic and neutral faintly alkaline solution respectively to O. So this is the part of D block. So in D block, MnO4 minus, right, it oxidizes I minus to I2 in acidic medium. In acidic medium. Okay. And MnO4 minus converts I minus to IO3 minus in neutral or mild basic medium. So answer is going to be 1. This is memory based. Memory based. Chemical reactions are given in NCERT. These chemical reactions are given in NCERT. Let's do next question. An aqueous solution of KOH, when for volumetric analysis, its concentration should be checked before use. Yes. Why? Because KOH can absorb atmospheric CO2. And if it can absorb atmospheric CO2, then concentration can change. Okay, so yes, on aging KOH solution absorbs atmospheric CO2. It is yes. So both A and R are correct, and R is the correct explanation of assertion. So option 3 is correct. Okay, let's do next question. Oxidation number of potassium in K2O, K2O2 and KO2 respectively is. So as you can see in this question, we have different types of potassium oxides. Different types of potassium oxides. So we know oxidation number of alkali metals. Oxidation number of alkali metals, it is +1 always, right? So if we have K2O, so it means this is 2K plus and O2 minus, so this is the oxide of potassium. If we have K2O2, so it means we can write this 2K plus and O2 2 minus. So this is the peroxide of potassium. If we have KO2, which KO2? So KO2 means, just give me a moment, yes. KO2 means this is +1 and this is O2 minus, right? This is O2 minus, or we can say K +1. So this is the superoxide of potassium. But in all the cases, oxidation number of potassium, it is +1, +1, +1. So answer is 2. Option is 2. Let's do next question. Question may we have two reactions. first HOCl plus H2O2 gives HCO positive Cl minus NO2, and in second reaction we have I2 plus H2O2 plus 2H minus gives 2I minus plus 2H2 plus O2. Choose the correct option. So if we see the option, we have to find out whether H2O2 acts as oxidizing agent and reducing agent in the above two reaction. So let's do it. So first reaction is HOCl plus H2O2, and it gives HCO positive Cl minus NO2. So if I write HOCl, मतलब if this is HOCl, so इसको we can write unknown column. इसको we can write as H plus and OCl minus. Okay, H plus and OCl minus, and here oxidation state is X. Chlorine is less electronegative than oxygen, so we write 1, it is equal to -1. So oxygen oxidation state is -2 over here, but chlorine oxidation state is +1, and here chlorine is in -1. Okay, so in first reaction chlorine from +1 goes to -1. Whereas H2O2, we know that in hydrogen peroxide, oxidation state of oxygen is -1, and oxygen in H2O2, right, goes from this oxygen, goes from -1 to 0, because here oxygen is in 0 oxidation state. So H2O2 oxidize, है ना? Oxidation of H2O2 occurs. So this is going to be the reducing agent. What is a reducing agent? Which reduces other and itself get oxidized. So here in this reaction, H2O2 is the reducing reagent. Okay. Now let's see option number 2, मतलब equation number 2. So this is I2 plus H2O2 plus 2OH minus, and it gives 2I minus plus H2O plus O2. Here also H2O2 is reducing reagent. Why it is reducing agent? To see, oxygen from -1 goes to 0 O2, right, due to the O2 formation, and I2 from 0 goes to -1. So I2 reduces. So that's why H2O2 is a reducing agent in this case also. So we can say that H2O2 acts as reducing agent in equations A and B. So option 3 is the correct answer. Now let's do next question. Okay, so this is the question of balancing, simple balancing question, acidic medium balancing. So see, we have MnO4 minus, C2O4 minus. We have to balance this in acidic medium Mn2 plus, right? And oxalate carbon is oxidized to CO2, right? Okay. We have to find out the value of C. Value of C means we have to find out the coefficient of H plus. Coefficient of H plus. So let's do the balancing step by step. So first we have to find out the oxidation number of the key element. So here this is X, -8 is equal to -1, which is equal to +7. Here it is +2. So there is a change of 5 electron. Now if we see the oxalate C2O4 minus, so this is 2x minus 8 is equal to -2. 2x is equal to +6. Here carbon 2, we have 2 carbons over here. So first we have to balance carbon, right? Here with respect to 1 carbon, oxidation state is X -4 is equal to 0. So X is +4. But we have to find out the oxidation state with respect to 2 carbon. So 2x is equal to +8. So here oxidation happens, which involves 2 electron change. Now first, so we have to balance electron. First we have to balance electron because 2x का value over here, it is +8. Okay, so first we have to balance electron. So on doing balancing, we have to multiply this with 5, and this should be multiplied by 2. So here we write 2, here we write 2, here we write 5, and here we write 5 2s are 10. Now last step, to balance oxygen. And in order to balance oxygen, we have to count number of oxygen atom. So here 2 4s are 8 and 5 4s are 20. So 20 oxygen atom, they are present on left hand side. Here 10 2s are 20 oxygen atom on the right hand side. So it means we have to write 8 H2O over here. Now we have to balance hydrogen. So here we have 16H plus. So here we have 16H plus, right? So coefficient of H plus, that is equal to C, which is 16. So the answer is 16 over here. Okay, let's do next question. Consider the following equations. Okay, so first equation we have to balance in basic medium, and second equation we have to balance in acidic medium. Okay, so first equation is Fe2 plus H2O2 gives Xa and Yb. So see, Fe2 plus H2O2, okay, and we get Fe3 plus, because Fe2 plus oxidized to Fe3 plus, and H2O2 reduces to OH minus, we can say. H2O2 reduces to OH minus. So here what we can write, Fe2 plus Fe3 plus, so there is a change of one electron. Okay. Now here 2 plus 1 plus 2x is equal to 0. So 2x is equal to minus 2. We have to balance oxygen atom product side. So here x plus 1 is equal to minus 1 and x is equal to minus 2. But with respect to 2x, we have minus 4. So here there is a change of 2 electron. It means we have to balance this first. So it means we have to write 2 and 2. Now this is in basic medium. So in basic medium, we have to balance charge. Let's balance charge. Okay, we have to balance charge. So देखो, how can we balance charge? So देखो इधर this is 2 2s are 4. Here total plus 4 charge is there. Here 2 3s are 6 plus 6 minus 2, that is equal to plus 4. It means charge is balanced, already balanced. Now we have to check for oxygen. Already balanced, right? Already balanced. Now we have to check for oxygen. So let's check for oxygen. So here we have 2 oxygen and here also we have 2 oxygen. It means oxygen is also balanced. So this is the balanced chemical equation. So from here x ka value is equal to 2 and y ka value is equal to 2. Okay, now let's do next question. So next question is MnO4 minus H2O2. Okay, MnO4 minus and H2O2, and we have to balance this in acidic medium. So MnO4 minus is converted to Mn2 plus and H2O2 is oxidized to O2. Okay, so let's find out. So here it is x plus 7 manganese ka, here it is plus 2. So there is a change of 5 electron. Here for oxygen ka we have for 2 oxygen we have minus 2, and here for 2 oxygen it is 0. So there is a change of 2 electron. It means now first we have to balance the electrons. So this should be multiplied by 5. So 5 and this should be multiplied by 2. So 2. Now we have to balance oxygen. So 2 4s are 8, 5 2s are 10, 28. Here we have 5 2s are 10. Okay. So 5 2s are 10 and 2 4s are 8, 18. So here we have 5 2s are 10. So here we write 8H2O. 8H2O, and then we have to write kitna? We have to balance hydrogen now. So here we have 8 2s are 16. 16 already. 5 2s are 10. Hydrogen is there. So it means we have to write 6H plus. Okay, we have to write 6H plus. From here x dash is equal to 2, y dash is equal to 5 and z dash is equal to 8. Now we have to add. From above x is equal to 2, y is equal to 2. Now just add all of them. So 2 plus 5 plus 8 plus 2 plus 2, right? So when you add, so 5, 6, 7, 8, 9, 10, 11, 11 plus 8, 90. So the answer is going to be 90. Answer is 90. Okay, ठीक है. Let's do next question. This is the balancing equation in basic medium. So let's do this by writing each step. So here S8 gives S2 minus and S2O3 2 minus. So this is a kind of disproportionation reaction. So I'm going to write one more time S8. Okay. So here x is equal to 0, here x is equal to minus 2. This is the reduction process, but we have to do with respect to 8 sulfur atoms. So here we write 8. So 8x is equal to 0 and 8x is equal to minus 16. So there is a change of 16 electron over here. Okay. Now for this one, x is equal to 0, 8x is equal to 0, and here 2x minus 6 is equal to minus 2, 2x is equal to plus 4, and x is equal to plus 2. But we have to find with respect to 8. So first we have to balance this sulfur. 4 2s are 8. So here 8x is equal to how much? 16. So here also 16 electron. Clear? So there is no need to balance the electron as they are already balanced. Now what we are going to do, I am writing this whole equation as 2s8 gives 8s2 minus plus 4s2O3 2 minus. 4s2O3 2 minus. Now on simplify, let's simplify this. So we get S8 4s2 minus, we get S8 4s2 minus and 2s2O3. 4s2 minus plus 2s2O3 2 minus, right? This is correct one. Okay. S8 4s2 minus and 2s2O3 2 minus. Up now next step is to balance charge. We have to balance charge. So here 4 2s are 8 minus 8 and here 2 2s are 4 minus 4. So total is minus 12. So we have to balance charge by adding OH minus to the deficient side. By adding OH minus to the deficient side. So here this is going to be 12 OH minus. Now last step is to balance oxygen. Now balance oxygen. Now balance oxygen. So here we have 12 oxygen and here we have 2 3s are 6 oxygen. So oxygen we have to balance by adding water. To deficient side. So we have to add 6 water. Okay. Hydrogen, they will get automatically balanced. 6 2s are 12 and this is 12. Okay. Let's do next question. This is the last question that we are going to do for the stoichiometry part. Rest you have to try other previous year questions on your own. And I have discussed enough number of questions. It's just you have to do the revision. You have to do more and more questions. That's it. Okay, let's do the last question for today's class. So 15 ml of aqueous solution of Fe2 plus in acidic medium completely reacted with 20 ml of 0.03 molar dichromate. The molarity of Fe2 plus solution is, so see, this is Fe2 plus and this is 15 ml. And we have dichromate Cr2O7 2 minus 20 ml and 0.03 molar. We have to find out the molarity of Fe2 plus. Okay, in 10 to the power minus 2. It means we have to find out the value of X. That is in acidic medium. So Fe2 plus is converted to Fe3 plus and Cr2O7 chromium is converted to Cr3 plus. So what we are going to do? We are going to apply the equivalent concept. Number of equivalents of Fe2 plus is equal to the number of equivalents of dichromate. So for here, first we have to find out n factor. So here oxidation state is +2 and here Fe +3. So there is a change of 1 electron. Here 2x minus 14 is equal to -2. So 2x is equal to +12 and x is equal to +6. And here x is equal to +3. So there is a change of how many electron? 3 electron. Now first calculate n factor of Fe2 plus. So only one atom of iron and there is a change of 1 electron. So n factor is 1. N factor of Cr2O7 2 minus. There are 2 atoms of chromium and there is a change of 3 electrons. So n factor is equal to 6. Now number of milli equivalents of Fe plus 2 is equal to number of milli equivalents of Cr2O7 2 minus. So here molarity into n factor into volume and here also molarity into n factor into volume. So molarity of Fe2 plus we have to find n factor 1 and 15. So 1 into 15 and here milli equivalents of Cr2O7 2 minus 0.03 into 6 into 20. Now on solving, we get 0.03 into 6 into 20 upon 15. So on solving, you get 24 into 10 to the power minus 2 molar. So you have to report your answer as 24. That is the answer. Okay, so we have discussed enough number of questions of this stoichiometry. Now you have to solve on your own. Just try to attempt more and more previous year questions so that you can have the clarity about what type of questions are coming in the exams. That's it for this video. I hope you understood everything. Okay, then see you in the next video. Bye. Take care.